Accidents involving pedestrians and cyclists are still a very important issue for road safety. They account for a very high percentage of the total number of road fatalities and serious injuries. Crash avoidance technologies with pedestrian and cyclist detection could definitely improve road safety. Some of those technologies are being developed under Prospect project. Its main objective is to lay foundation for next generation active safety systems.
Within Prospect, we developed and assembled 3 vehicle demonstrators, which feature novelties on the hardware side as well as on the software side. On the hardware side, we integrated an increased number of recent radar and camera sensors, which feature a higher field of view as well as a greater resolution. On the software side, the recent advances in machine learning allows us to extract more and more meaningful features from those sensors. For instance, besides solely detecting the presence of a cyclist, we're also able to detect if the cyclist is indicating his intention to turn. Therefore, the car is able to react to those vulnerable road users in a more naturalistic, human-like way and therefore overcome challenges of the current generation. At the end, we integrated those systems into the test vehicles to measure the increase in performance compared to the current systems, but on the other hand also to aid the novel test methodologies which are developed within Prospect.
Here at the University of Nottingham, we've been particularly interested in drivers' acceptance for the novel technologies being developed by the Prospect project. So for our research, we've made extensive use of our driving simulator facilities, which allow us to investigate the key human factors issues in a safe and a controlled environment. So we carried out a series of studies using the driving simulator to investigate the effects of false alarms on drivers' acceptance for the Prospect system. A key finding of our research was a demonstration of the importance of the human-machine interface, particularly its transparency, how it explains to the human driver what just occurred during the false alarm scenario.
So what we're trying to achieve here on the test track is basically 2 things. First is to evaluate the performance of our prototypes that were developed within Prospect. And secondly, we are gaining some hands-on experience with the new intersection scenarios. We are addressing a lot of challenges regarding the new trajectories and speed profile, as well as robot tuning issues. The overall goal is to make consumer testing more realistic in the near future and to provide to traffic safety.